good to see you, good to meet you, and good to have you all in the second workshop. And so again, to have a little intro, my name is Faria Yusuf, and I am really thankful to all of you who joined the workshop, the previous workshop, uh, and for the interactive sessions that we have on our WhatsApp group. And I'm really, really grateful and happy to see such a positive interaction and a positive attitude. So really a great applause to all of you. And mensuration is the topic that we shall be doing today. But to before starting mensuration, then यही बताना चाहूंगी who am I, क्योंकि बहुत से लोग अभी नए भी join कर रहे हैं. So my teaching experience expands like more than 27 years, or since 1998 I've been teaching Cambridge. और जाहिर है progression होती है, तो started with O levels and then A levels, and in इस पूरे दौरान में अल्हम्दुलिल्लाह amazing results from the students. बहुत अच्छी interaction रही, बहुत अच्छी journey रही with all the students, and I would really like to mention the 4 of my students who managed to get world distinction, the outstanding learners award. So there are 4 of them. One got the world distinction in AdMath, the second one in math for at Pakistan level. Then there are 2 of them. 2 years back, Amna Basti, she got outstanding learning award in A-level math. And then this year, my student Rayan, he got World Outstanding Learners Award for Mathematics 4024. So Alhamdulillah, it has been a great journey, and I'm really, really thankful to Allah for everything. और सबसे बढ़ के ये कि बहुत अच्छे स्टूडेंट्स के साथ वास्ता रहा, और बहुत अच्छी इंटरेक्शन रही, एंड कभी भी कोई चीज एक तरफ से नहीं होती. सो आई मस्ट से इट्स लाइक बोथ वेज, और स्टूडेंट्स अच्छे मिले जिन्होंने मेहनत की, और फिर जाहिर है उसका उन्हें अवार्ड रिवॉर्ड भी मिला. So this is a little introduction of mine. और ये कि I have my YouTube channel also. It's a baby YouTube channel. उस पे मैंने सिर्फ A-level math Pure 1 के lectures complete course upload किया हुआ है. And the channel is with the name of Mathcast with Faria Yusuf. So अगर थोड़ा सा आप देखना चाहते हैं कि और मैं मजीद किस तरह से पढ़ाती हूँ और मेरा क्या स्टाइल है, so you can just visit the channel also. So अच्छा, आप में से किसी एक ने मुझसे पूछा था कि अभी एट द मोमेंट जाहिर है आप लोगों के सामने मार्क्स के ग्रेड्स हैं, तो विद दोज ग्रेड्स आप लोग आगे कहाँ तक जा सकते हैं. सो आई मस्ट से, जब आप मार्क्स का एग्जाम देते हैं तो ऑलरेडी आप बहुत प्रेशर में होते हैं, आप स्कूल भी जा रहे होते हैं, लाइक देयर आर थिंग्स गोइंग ऑन, सो मेनी एक्टिविटीज ऑल्सो. तो उसमें जिस तरह से पढ़ना होता है, पढ़ना चाहिए है, शायद बहुत से लोग उस तरह नहीं पढ़ पाते. बट आफ्टर मार्क, दिस इज द टाइम जिसमें आपने अपनी वो जो कहते हैं ना कि पूरी जान लगा देनी है. सो दिस इज द टाइम जिसमें आपने जान लगा के लाइक 100% अपनी पूरी मेहनत करनी है. दिस इज द टाइम, अगर आपके पास आपका मार्क ग्रेड इस वक्त सी भी है, डी भी है, यू कैन वर्क हार्ड and you still can achieve an A or an A star. I really मतलब इतने सालों में मैंने देखा है स्टूडेंट्स को मार्क्स में जो किसी पे खड़े हुए थे, वो 1-1.5 महीना इतनी मेहनत की कि वो A और A स्टार पर आ गए. एंड दिस इज पॉसिबल लगता है, स्पेशली एट दिस लेवल, कि बहुत आसानी से हो सकता है. The only thing is work hard. Don't look at what you got in your marks. Just aim for what you should be doing to improve that grade. Forget the fact कि आपका मार्क में क्या ग्रेड था. Forget कि आपने पास्ट में क्या किया था. Just focus on what you have to do now. And this is the time. So just work hard. Just bring your grade from C to an A star, and I will be really proud of you. I will be really proud of you. And again, repeating, this is possible. This can be done. So I will be praying for you all, and I wish you all the best, and inshallah, you will all do it. Inshallah. All right, so starting mensuration. सबसे पहले mensuration में जाहिर है हमें पता है mensuration starts with shapes, and first we have to have 2D shapes और फिर उसके बाद we'll come to 3D shapes. बहुत जल्दी हम recap कर लेंगे कि mensuration हमारे syllabus में इस वक्त कौन कौन से shapes हैं और हमें इसका area और perimeter पता होना चाहिए. One more thing, paper में formula list आपको दी हुई होती है, but that formula list does not cover 2D shapes, right? It does have 3 shapes, उनके areas और surface areas और उनके volume, but 2D shapes का surface area और volume आपके पास, sorry, not surface area, 2D shapes का area और perimeter आपके पास नहीं given होता. So these are the things, these are the formulas that I have compiled here, and you should be knowing these formulas by heart, right? ये provided नहीं होंगे. So first is the square. Square में it's all it's a four-sided figure. And for the four-sided figure, square, all equal sides, the area is L square and the perimeter is a 4L. आप बोल रहे होंगे कि ये तो बहुत ही babyish बातें हैं, but yes, these are the start, it's the start of geometry, but then we are just revising it, right? Rectangle, it has 2 pairs of parallel and equal sides. So one is this pair and the other is this pair. Parallel and equal sides, meaning I can say this is length times breadth, and the area is length into breadth, and the perimeter is given as twice of L plus B, the breadth. Parallelogram, for parallelogram, the area, all right, what is a parallelogram? Again, there are 2 sets of parallel sides. There are 2 sets of parallel sides. These 2 are the parallel sides here. And then the area is given by the breadth, the width times the height. And always remember, height is always the perpendicular height. It's the vertical height, right? Do not confuse your height as L, which is the slant height. The area of parallelogram is base times the vertical height. And the properties are opposite angles are equal. These 2 opposite angles, they are equal. Diagonals bisect each other. Bisection का मतलब होता है कि ये midpoint पर diagonals एक दूसरे को bisect करेंगे. This should be the midpoint here. Bisection always means, या bisector always means passing through the midpoint. Please have your notebook, have your pen with you and start taking notes. Bisector, बहुत से students को ये concept नहीं होता. Bisector, that means it should be the line, or it should be the line which is dividing the given line into 2 equal parts. That means it should be passing through the midpoints. अगर midpoint से pass हो रहा है तो obviously AX or XC, both of them they will be equal. DX and XC, XB, again, they will also be equal. And then opposite sides are equal. What is the perimeter of a parallelogram? It's twice of base. Now we should say it's base times base plus the slant height, which is L in this case. अच्छा, अगर यही height हम इसको straight कर देंगे, vertical कर देंगे, obviously it will turn into a rectangle. This is the difference between parallelogram and a rectangle. Then we have rhombus. Rhombus, all sides are equal. All sides are equal. Opposite angles are equal. Opposite angles, they are equal. And diagonals again bisect each other at right angles. यहाँ पे ये एक property है कि rhombus में bisection is at right angles, meaning the angle that I should be having here at this point, let me make it here with a different color so that you know what I am talking about. These are the diagonals, and this will be making 90 degrees, right? It's the bisection, but the diagonals bisect each other at right angles. So what is the perimeter? Perimeter is the sum of all the sides. And what is the area? The area is again base times the height. The area is again, forgot to write that. The area is again base times the height here. All right, then it's trapezium. Trapezium, all right, so trapezium, we have the area, which is half times sum of parallel sides time height, or we can say it's 1/2 sum of parallel sides, meaning if these 2 sides are parallel, then I should say it's 1/2 L1 plus L2 times the height. And what is then the perimeter? The perimeter, obviously, it's going to be A plus B plus C plus D. We should be knowing perimeter is actually the sum of the boundaries, the sum of the lengths of the boundaries. So if this is the boundary starting from here, it's A plus B plus C and then plus D. So this is then going to be the perimeter here. And then for the kite, how do we get the area of the kite? Area of the kite, just divide it into 2 triangles. And then we know how to get the area of a triangle, and I'll explain that too. So, and what is the property of kite? The opposite sides may or may not be parallel. Opposite sides may or may not be parallel. Two pairs of equal adjacent sides. So one pair is this. There are two equal sides, and the other pair is these two sides. So both the triangles A1 and A2, they will be making an isosceles triangle for the kite here. And then we have the diagonals which cut each other at right angles. So diagonal cut each other at right angle. And keep in mind कि kite का diagonal bisector नहीं होता. ये midpoint नहीं है. Can be the midpoint for this line. Let me write it as AB. It can be the midpoint of the line AB, but it's not the midpoint of CD. All right, so we cannot say that the diagonals here, it is intersecting at the midpoint of A and B, but not for CD, right? अगर CD का भी midpoint होता, तो जाहिर है वो फिर rhombus में convert हो जाता. Provided के चारों sides parallel होते. अच्छा, and then what is the sum of, what is the perimeter? Perimeter has to be the sum of all the sides. Then it's the triangle. हमें पता है triangle is very general. I expect everybody to know कि triangle का जो area है, that is half into base into height. अगर right angle triangle हो और अगर right angle triangle नहीं है, then it's half into AB into sine theta. And when we say it is AB into sine theta, always remember when you are applying this formula, the two adjacent sides, and the inclusive angle. These are the two adjacent sides. So sine theta, this has to be the inclusive angle here, right? So the two half AB sine theta, that means the two adjacent sides, the product of the two adjacent sides, and then their adjacent or the inclusive angle. This is the angle, right? अगर मैं इसको इसी तरह से AC के साथ solve कर रही होती, तो I would have said it's half AC. Let me label that. So half ABC. So I would have said this is half AC and then sine of B here, right? So this is the basic thing about the area of a triangle, provided that it is not a right angle triangle. And then what is the perimeter? Perimeter is the sum of all the sides. Obviously, it's going to be A plus B and then plus C. So this is going to be your perimeter here. Then for circle, like circle, the area is pi r square, the diameter is r. Circumference is actually the perimeter of the circle. Perimeter of the circle is called the circumference. That's the boundary of the circle. So circumference is 2 pi r, diameter is given as 2r. So you can also say that circle is a pi d, right? 2r written as a diameter. It can also be written as a pi times diameter. Then for semicircle, the area becomes half of it. So it's half pi r square. And perimeter of this semicircle, it's this arc length, it's this semicircle here, which should be 2 pi r divided by 2. And then it should be the diameter. So this is the perimeter of a semicircle. So this is pi r plus d. And for sector, what is a sector? Sector is a part of the circle. So we have the center of the circle going up till the circumference. And if these are the 2 points on the circumference of the circle, then we can have this arc length here. So it's part of the circumference, which is the arc length here. And the inclusive angle, it's the theta at the center. And then we have the two radii. So how do we get the area of a sector? It's theta over 360. 360 because complete rotation is for 360 degrees. So it's theta over 360 times pi r square. And then how do we get the arc length? It's theta over 360 times 2 pi r, right? So arc length, I've written the arc length AB here also, theta over 360 into 2 pi r. And then if you're supposed to get the perimeter of this sector, then you should say that it is this radius plus radius and the arc length AB. So in other words, I can say it's 2r, r plus r, that's a 2r, plus the arc length of AB here. So this is going to be the area of the sector. And another thing here, which I should mention, is that if this is your angle theta, then the outer angle is called the reflex angle. And this reflex angle is always 360 degrees minus theta. Reflex angle, it's always taken as 360 theta. So these are the two, these are all 10 2D shapes that I have compiled here. And these formulas, they will not be given the formula list of your examination paper. You need to know them by heart. Coming to 3D shape, again, I have compiled the 3D shapes here. The first one is a cube. I have the cube here. What is a cube? All sides are equal. Length, breadth, height, all of them are equal. What is the volume? It's given as L cube. And also, if they ask you to make the net, then this is how you will be making the net. In a cube, how many faces are there? 1, 2, 3, 4, 5, and then 6. 6 faces here. So this is how the net is made for a cube. And the surface area of the cube is given as 6L squared. What actually is the surface area? The surface area is actually each face. For each face, you have to get the area of the face, and then we add up all the areas of all the faces. If for the cube, it's a special case where I can see all the faces, they will be having the area which is an L square, L times L. So all the faces, 6 faces are there. So I should say that the surface area here is a 6L square. For a cuboid is when length, breadth, and height, they have different dimensions. So if this is length, breadth, and height, this is how you should be making the net for this cuboid. And the surface area of the cuboid is twice of length times breadth. Length times breadth. It's twice of length times breadth. Length times height, and then height times b. So what is happening here is, or what I'm saying here is, I have the front face, which is L times H, right? L times H. Here I can see this is L times H also, right? So I have this L times H, all right? So this space, obviously L times H, it's in the front and it has to be at the back also. That is why I'm writing this as a twice. So it's L times breadth here. Then I can see it's breadth times height. So this is breadth times height, this side. And then I can see that this is length times breadth also, right? Height times b, and then length times height. So these are the 3 faces that I have: length times height, breadth times height, and then length times the breadth. And every face is present on the opposite side. That is the reason that I have multiplied all these areas by 2, which represents the 2 faces on both the sides, front and back. And this is what the net is going to be for a cuboid. Cylinder. Now for cylinder, it's the volume. Always remember, whenever you have a 3D shape, then the basic volume formula is base area times height. So whatever the base area is, you just need to multiply it by the height. So it can be the circle, making it a cylinder. It can be a square, turning it into a cuboid. It can be a rectangle, again, turning it into a cuboid. And then if the square and the height, that is the same, it will be the cube then. So it's always the base area, always. It's the base area which should get multiplied by the height. In case of cylinder, the base area is a circle. So I should say it's a pi r times height, and then this is going to be the volume of a cylinder. So volume of a cylinder, and what is the curved surface area? The curved surface area represents this part, right? This is the part which represents your curved surface area. The base here is a circle. The top here is also the circle. And this part here, this part here, this is my curved surface area. How do I get the curved surface area? I can see that I have the circumference throughout the curved surface area, which is going throughout the height. So I can say that this circumference 2 pi r multiplied by this height, this should be my curved surface area. Curved surface area 2 pi r times height. What is the base area? That's a pi r square. So if I need to get the surface area of the closed cylinder, then I can see I have the base area pi r square. I have the top also, which is a pi r square, and then it's the curved surface area, which is represented by this side, and that is a 2 pi r h. So surface area becomes 2 pi r plus 2 pi r square, 2 pi r h plus 2 pi r. 2 pi r h, the curved surface area, plus 2 pi r. So this is going to be the surface area of the closed cylinder. And sometimes the cylinder might be an open cylinder. Just imagine the Pepsi can or 7-Up can or any can that you have. So if the top is just open, then obviously to get the surface area, I will say that there is no top. Therefore, it's just the base area which will be left with you, the base area left with you, and then the curved surface area. So we have a 2 pi r h plus pi r square. How do we make the net of the cylinder? Net of a cylinder, we have the circle, we have another circle, and then if I open this curved surface area, if I cut it here and I open it, I will be getting this straight rectangle, right? So how to make the net? We have this straight rectangle, and this then is actually the circumference of the circle. Obviously, you are opening it. You are opening the circumference. You're opening this circle. That means when I straighten it up, this is actually representing the circumference of the circle. Height remains the same. Height remains the same. And then I will be having the top here and the bottom surface here. If there is no top, obviously I will not be making it on my net. So this is the net for the cylinder, and this is how I will be opening it to make the net here. So I hope up till here everything is clear. And if there is any query, I'll just go back to your queries once I finish the explanation for the other 3D figures that I have here. So don't worry, everything will be explained and the queries will be resolved. Just wait for your turn. Triangular prism. Triangular prism, word suggests the base has to be a triangle, right? So the base here is a triangle, and then it's a prism. We have a constant depth throughout, the constant height throughout. So what is, again, the volume? It's the base area, which is the triangle, times the height here. Volume is 1/2 into base into height for the triangle, base area, and then multiplied by depth. And the surface area is, obviously, I have two triangles, one at the base, the other at the top. So I can say it's twice of base area plus how many faces do you see here? If I just open this triangle, the top triangle, it's here, the bottom triangle, it's here, and then the faces, this is my front face. So this is the front face here. And then I can see I have two more triangles, sorry, rectangles, two more rectangles. So there are three rectangles, and then the top and the bottom, which is a triangle. So this is how I will be making the net for the triangular prism. And then whatever the shape is, you can just have the shape on this side of the prism that is given to you. So surface area, we know it's surface area twice of base area plus 3 rectangle areas. Another way of getting the surface area, now I do find students getting confused कि surface area find करने में कौन कौन से faces आ रहे हैं. They do get, there is always a confusion with the students. So इसको short या simplify करने के लिए I apply the formula provided that you have a constant, right? A straight height, constant meaning a straight height, right? Which is D in this case. It's a straight height. So for that, perimeter of the base meaning perimeter of this triangle. I can say it's the perimeter of the triangle and then multiplied by the depth, right? This will give me the perimeter of the base times depth. This actually will give me the sum of the areas of all the three faces. Obviously, अगर मैं इन तीनों को sum up कर रही हूँ, I'm taking this into consideration, this also into consideration. I could see अगर मैं इन तीनों को अलग अलग solve कर रही होती, तो ये इस height से multiply हो रहा है, ये इस height से multiply हो रहा है, और फिर ये भी इसी height से multiply हो रहा है. So just to shorten my working, to simplify my working, I'm saying it's the perimeter of the base, right? Perimeter of the base, triangle. इसको किससे multiply करना है? Just multiply by the depth. And then obviously you have the top, you have the bottom. इनका भी आपने twice of the base areas, जो भी base areas आपके पास हो. So this is all about triangular prisms here. कोन, अच्छा, कोन, अब कोन में क्या होता है कि कोन में आप you can see कोन के shape में you do not have a straight height, it's the slant. You get a slant here in a cone, right? A common example, your birthday hats जो बच्चों को पहनाए जाते हैं, that is a cone, right? ये जो slant height है, यहाँ पर cone में we do not have a straight height for the cone figure, it gives you a slant height. So just remember, आपके पास जो shapes आएंगे जिसमें slant height मौजूद है. We do not have a constant depth throughout, right? A straight vertical constant depth. Over there, volume formula is for 1/3 into base area into height. What is the base area? That's your circle. 1/3 into pi r square. This is the circle times height. So always remember 1/3 हम उस वक्त apply करते हैं जब आपके पास depth straight नहीं होती, बल्कि you are getting something which is a slant. So this is the volume formula for the cone, 1/3 of base area, pi r square times height. Again, अब अगर ये slant height है, तो ये slant height किस तरह से find की जाए? You can see from the vertex or the apex of this cone, अगर मैं नीचे straight vertical line draw करती हूँ, so I will get the height of the cone, and then the radius and the height, they will be making a right angle triangle. With this right angle triangle, applying the Pythagoras theorem, I can say it's L, which is equals to h square plus r square. This is the right triangle that I am getting in terms of the height of the cone, the radius, and the slant height. L is called the slant height. और फिर ये कि surface area, अगर मुझे इस cone को अगर मुझे इस cone का net show करना है, तो how am I going to show the net? Again, cut it from the apex, cut it from the vertex. जैसे ही आपने इसको कट करके इसको ओपन करना शुरू किया, यहाँ से कट करके, when you start opening it, what do you see? ये जो circumference है, ये open होता चला जाएगा. अब ये circumference, how were you representing the circumference? It was a 2 pi r, right? Circle है, तो obviously circle का circumference is a 2 pi r. हमने यहाँ center से इसको cut किया, और जब हम इसको open कर रहे हैं, तो this is how you will be getting your circumference. So this is your 2 pi r, and then this part is your slant height, which is your L. This part is your slant height, which is your L. So this is the surface, this is the net of a cone here. ठीक है. अच्छा, अब surface area अगर मुझे इस पूरे cone का निकालना है, तो I can see I have the base area here, and then I have this curved surface area, this curved surface area. So the surface area of the entire cone, अगर वो closed है, I should say it's a closed cone, right? There is this bottom circle there. So I can say that now it's the base area, pi r square, plus the curved surface area is given as a pi into r into L, pi r L. And how do we find L? It's square root of h square plus r square. So the surface area for a closed cone is pi r square plus pi r L. And if it is an open cone, meaning the base is not there, then in this case, the surface area is just going to be pi r L. And then we have the sphere. For this sphere, what is a sphere? It's just a ball. Volume of the sphere is given as a 4/3 pi r cube, and the surface area is given by 4 pi r square. परेशान होने की जरूरत नहीं है. 3D shapes के सारे formulas आपको पेपर में given होंगे. I am just trying to explain कि ये बन किस तरह से रहे हैं. अगर हमें like L find करना है, तो L जाहिर है हमें find करना होगा questions में, तो हम L किस तरह से find करेंगे, या curve area क्या होता है. So this is the explanation that I'm doing here. Sphere, and then what is hemisphere? Hemisphere is half of the sphere. अगर इस sphere को आप बीच में से काट दें, like आप सब ball, tennis ball अगर आपने देखी हो, यकीनन देखी होगी, अगर वो पूरी tennis ball है, तो that's a sphere. अगर आप उसको बीच में से काट दें, तो it becomes a hemisphere. So hemisphere, what is the hemisphere? जाहिर है हमने उसको बीच में से काटा है, so it has to be half the volume of the sphere, which is 1/2 into 4/3 pi r cube, or I can say it's a 2/3 of pi r cube. So what is going to be the surface area? Surface area then is going to be half. अच्छा, अब सिर्फ ये एक special case है कि अगर इसमें आपके पास top मौजूद है, if in this hemisphere you have the top, then you know that it is the circle, so it has to be it has to have the area, which is a pi r square. So the circular base, pi r square, surface, curved surface area here, of the sphere का surface area है, which is a 4 pi r square, ये उसका half हो जाएगा. So the surface area becomes a 2 pi r square, circular base pi r square. I can say for a closed hemisphere, a solid hemisphere, the surface area is 3 pi r square. जबकि अगर यही open होगा, so obviously I will not be having this pi r square. I can say that the surface area is just a 2 pi r square. Half of the surface area of the sphere, curved surface area of the sphere. and that's just a 2 pi r square. फाइनली पिरामिड है, और पिरामिड में क्या होता है, पिरामिड में सारी ही साइड्स स्लांट है. यू कैन हैव अ रेक्टेंगुलर बेस, यू कैन हैव अ स्क्वायर बेस. इसमें all the sides they are slant heights. So again slant heights मौजूद हैं, तो आपके पास वॉल्यूम में 1/3 has to be there. It has to be 1/3 of the base area. अब चाहे ये स्क्वायर हो, चाहे ये rectangle हो, you can just apply this base area formula here and then multiply it by the height, and we know what the height is. Starting from the apex, just go down up till the midpoint of the square. So this will give you the height. So it's volume 1/3 of base area into height. And then surface area is actually the total area of all the faces. That means अगर ये net है for the pyramid, for this net, अगर मुझे surface area find करना है, so it's going to be the square area plus this triangular area plus this triangular area plus this triangular area and then plus this triangular area. And then obviously the two opposite areas ये equal हो सकते हैं. So I can also multiply the two areas, the area of this triangle by 2, the area of this triangle by 2, and then plus the base area, which can be a square or a rectangle. So I hope everything is clear. एग्जामिनेशन पॉइंट ऑफ व्यू से आपसे क्या एक्सपेक्ट किया जाता है मेंसुरेशन में, दैट इज योर यूनिट्स. यूनिट्स, ये सारे यूनिट्स हैं जो कि इंक्लूडेड हैं. जो कॉमन मिस्टेक्स मुझे नजर आती हैं स्टूडेंट्स विच स्टूडेंट्स मेक, दैट इज द कन्वर्जन, स्पेशली जब वो लीटर्स को मीटर क्यूब या मिलीलीटर्स या सेंटीमीटर्स में कन्वर्ट कर रहे होते हैं. सो दिस इज द कन्वर्जन दैट आई हैव रिटन. 1 meter cube is 1000 liter, 1 centimeter cube is 0.001 liter, which is actually 1 milliliter, or 1000 centimeter cube is a 1 liter. So ये conversion please note them down. I hope everybody is taking notes. और फिर यही है कि area perimeter हमें किस तरह find करना है. We have discussed all of them. Surface area and volume we have discussed. Cuboid, prism, cylinder, sphere, pyramids, and then cone. All of these I have discussed. Circles, arcs और sectors ये भी हमने discuss कर लिया. और फिर कंपाउंड शेप्स क्या, कंपाउंड शेप्स में लाइक यू कैन हैव डिफरेंट 3D शेप्स, या अगर 2D शेप है तो 2D शेप कंपाउंडेड का मतलब है टुगेदर. लाइक a shape can be of a cylinder and then a cone, a cylinder or a hemisphere, can be anything. So these are the compound shapes. और उसमें अब जो एक चीज यहाँ पे बहुत क्लियरली उन्होंने लिखी थी, that is find the surface area and volume of a frustum. So I hope you know what a frustum is, but अगर नहीं पता है तो I will start the explanation of a frustum and then we'll move on to our past paper queries. But then before that, I need to see if there are any queries. Let's do that. Okay. So I have the participants here. So, oh my God. Yes, what is frustum? Yes, I'm going to just tell you what frustum is. Okay. Yes, you will get the notes, but I would really appreciate if you start taking screenshots, or please take notes in your diaries also. And then we have, what's the teacher's name? Faria Yusuf. I'm Faria Yusuf here. अपराइट के अलावा शेप्स बिल्कुल हमने डिस्कस कर लिए कि अपराइट शेप्स के अलावा, और फिर उनका वॉल्यूम क्या होता है वो भी आपको बता दिया कि वॉल्यूम अगर अपराइट शेप नहीं है तो वॉल्यूम इज 1/3 ऑफ द बेस एरिया टाइम्स द हाइट. राइट. सो ओके, सो लेट मी स्टार्ट व्हाट फ्रस्टम इज. ऑलराइट. अच्छा, ये भी यहाँ पे आपको जो एग्जाम में फॉर्मूला लिस्ट दी जाएगी, सो यू कैन सी यू हैव द फॉर्मूला लिस्ट. दिस इज व्हाट that will be given in your examination 4024 paper. ठीक है, ये सारे again repeating, यहाँ पे formulas 3D figures के हैं, formulas 2D figures के नहीं हैं, but again you can see surface areas के formulas आपके पास नहीं हैं. So please notes, I hope you have all taken the notes, but we'll try to provide you with the recording also ताकि आप ये सारे notes ले सकें. But You should be having this with you also. What actually is a frustum? Yes, आप लोग को पता है कि frustum क्या होता है. तो frustum start करते हुए आपके पास कोन है, right? इस कोन में से अगर हम एक small cone का portion remove कर देते हैं, like this part, if I remove this part, then the remaining part is called the frustum, right? What is the remaining part? This is my remaining part. This part here, this is called frustum. ठीक है? So this is the knowledge that they would expect you to have. You can आपने भी देख ही लिया कि मैंने आपको notes की expectation बता दी कि इस वक्त आपसे क्या expect किया जाता है, what to know and what not to know. तो frustum की definition या frustum के बारे में आपको इस वक्त पता होना जरूरी है. So they expect you to know what frustum is. So what is a frustum? From the cone, if you remove a small cone, then the remaining part is called the frustum, meaning this here is called a frustum. This is our frustum here, this part. Okay, this part, this is going to be my frustum. ठीक है, अब frustum के लिए अगर मुझे area और volume find करना है, so I will be using the similarity method, and for the similarity method, what you can see is we have the cone, the bigger cone. Isme you have the height of the cone and you have the radius also of the cone, of the bigger cone. Let's write this as capital H and the radius as capital R. यही अगर हम small cone को remove कर रहे हैं तो इसकी भी कोई height है, let's call it small h, and इसका भी कोई radius है, let's call it small r. So by similarity, if I compare ABC to AXY, right? ABC to AXY. Then by similarity, what you can see here is that height can be compared to the height of the small cone. So it's h over small h, and the radius of the bigger cone can be related to the radius of the cone which has been removed to get the frustum. So this is h over h, which is equals to capital R over small r. So इस तरह से हम फ्रस्टम ऑब्टेन करते हैं और फ्रस्टम की फिर मजीद वॉल्यूम या सरफेस एरिया की कैलकुलेशंस बन सकती हैं. So let's do this question regarding frustum. Now I'm starting past papers, so please everybody pay attention. So here so here they have given us the frustum. The diagram shows a bowl. They did not. The diagram shows a bowl in the shape of a frustum. The diagram shows a bowl in the shape of a frustum. Calculate the volume of the bowl, right? So we have the understanding that the frustum is actually obtained when a small cone has been removed from the larger cone. So in this case, what I will be doing is I will be making the frustum. Let's make the frustum here. I have this frustum here. And what I'm saying is, to get this frustum, जाहिर है मैंने एक small portion of the cone को एक bigger portion के साथ remove किया है, right? So if I redraw the figure, what I can see here is that this is the frustum that I had. Okay, जो given frustum है उसका radius is 8 और जो smaller है यहाँ पर उसका radius is a 6, and the height of this whole cone, no, not the cone, the height of this frustum is a 9 centimeters. Okay, all the units, they are in centimeters. I need to have the volume of the bowl. How do I get the volume of the bowl? So to get the volume of the bowl, obviously frustum is not a regular shape. We do not have a specific volume formula to get the volume of a frustum, but then what we know is that from the bigger value, from the bigger cone, I have removed the smaller cone. What is the smaller cone? This is actually the smaller cone, right? So ये थोड़ा सा मैंने इसको पूरा shape देके I have said कि alright, यहाँ पर हमारे पास cone भी है और हमारे पास एक smaller cone भी है जिसको हमने remove कर दिया to get the obtained figure which is given to us. अब मुझे इसकी height नहीं पता. This is my x which I do not know. So if I compare the height of the bigger cone, right, जो कि actually पहले मौजूद था, I can say that this is my capital H and this 9 is the height of the frustum, right? और ये जो height आपके पास बन रही है removed part की, can I say that this is my x? और फिर radius के लिए I can see for the smaller cone, 6 is the radius and for the bigger cone 8 is the radius. तो अगर मैं इनके heights और radii को compare करती हूँ, so what will I be getting? I will be getting something which is h over small h, right? Small h is this height from this till this, which I have written as x. And then this is equals to the radius of the bigger cone divided by the radius of the smaller cone, जो कि remove हुई है to have the frustum with us. What is capital H? Capital H is a 9 plus x. What is the small h? That is an x. What is capital R? That's an 8. And what is small r? That's a 6. So in this way, I can very easily get the x value. I can resolve this. I can say this is a 4 and then this becomes 3 times 9 plus x, which is equals to 4x. Or I can say that here, this is 27 plus 3x, which is equals to a 4x. Or I can say that it's a 27, which is equals to 4x minus 3x. Or it's a 27, which is equals to x. So I have this x, which is equals to 27. And what is actually 27 here? 27 is actually the height of this cone, right? 27 is the height of the cone. Therefore, the small value here is, sorry, 27 is actually not the height, but this is capital H. This x value here is obtained as a 27. If they are saying what is the volume of the frustum, constantly हम यही बात कर रहे हैं कि volume of the frustum is actually the volume of the bigger cone, minus volume of the small cone, right? So अभी भी अगर किसी को नहीं समझ आया है तो मैं यहाँ पर इसको colored कर देती हूँ कि this is your small cone here, जिसको हमने remove किया था bigger cone से to obtain the frustum. This is my smaller cone. And obviously the bigger cone that is there. और हम किसका area find कर रहे हैं? हम किसका volume find कर रहे हैं? We are finding the volume of this frustum now. अच्छा. So how do we get the volume of a cone? We know that the volume of a cone is given by the formula. Volume of a cone is 1/3 of the base area, which is the circle in this case, times the height. ठीक है? So volume of the frustum, bigger cone के लिए, it's 1/3 pi r square. So bigger cone, the radius is r square minus into the height, which is capital H. And here I can say it's 1/3 pi small r squared times the volume of the smaller cone, which I have written as h or x. I can take this 1/3 pi common. So it's 1/3 pi common here. And then what I'm left here is 8 squared times what is going to be the height? The height here is going to be 9 plus 27. What is 9 plus 27? That's a 36. So it's 8 squared times 36 minus r squared. What is the small r? That's the radius 36. What is your x? That's a 27. So volume of the frustum then is going to be 1/3 pi, and then it's going to be 64 into 36 minus 36 into 27. And then you can calculate the volume of the frustum, which then is equals to 1332 by 3 pi. Or I can say that the volume of the frustum is a 444 pi. Or if you want to give your answer in decimals, you can also give the answer in terms of decimal. Then I can say it's a 444 times the pi value, which is giving me 1394. Volume of the frustum, it's 1394.86, or I can say that this is a 1395 approximately centimeter cube. So this is how you will be calculating the volume of the frustum. So I hope it's clear to all. And again, moving to the next question here, that is also again for frustum. और उसके बाद फिर हम जल्दी जल्दी क्वेश्चंस आगे करेंगे ताकि हम मजीद क्वेश्चंस को रिजॉल्व कर सकें. P817, let's do it quickly. All right, so a right cone has a radius of 15 centimeters and a height of 40. They have given us the radius and the height of 40 centimeters, and the cone is filled with lemonade to a depth of 25 centimeters. So we have the cone up to a depth of 25. We have lemonade up to the depth of 25 centimeters, meaning this is your lemonade here. So show that the radius of the top surface of the lemonade is 9.375. So how to get that? Obviously बहुत clear नजर आ रहा है कि अगर मुझे इसके top surface का radius find करना है, I need to have the radius of the top surface of the lemonade, right? So this is my lemonade, this is the radius of the top surface. So simply solve it by ratio, compare the heights, this bigger height, the total height to the small height of the cone, the bigger radius to the small radius of the cone, and you can say it's a 40 over 25, which is equals to a 15 over the radius here, and then the radius then can be a 15 times 25 divided by 40. So it's a 3 and it's an 8, and then solving it further, say that this is a 75 by 8, and 75 by 8 is actually a 9.375 centimeters. So this is your first part. It is shown. So after doing that, always write shown and never forget to box answers. Calculate the, anyways, यहाँ पर अगर मुझे where were we? We are just supposed to find the capacity of the empty part of the cone. So obviously for the capacity, it's just the repeated process that we have done in the previous question. For the empty part of the cone, you just need to have the volume of the bigger cone, which is 1 by 3 pi, 1 by 3 pi, and then volume of the bigger cone. So obviously it has to be 15 the whole square, the radius squared, times the height, and the height of the cone is a 40 minus small r, which we just found as 9.375 the whole squared times 25. And then you can calculate the volume of the frustum here, right? And because I can see that many of the students are, for them, maybe this is a new thing. So we can do the same for question 3, which I have compiled, but that we are really short of time. So I have explained a lot about the frustum. Okay, so the volume of the frustum here, when you solve it, for the second one, it's going to be the answer, which is 7120 centimeter cube. This is your 7120 centimeter cube, but in the question, they have said, give your answer in letters correct to 3 significant figures. So correct to 3 significant figures, and also in letters, we should know the conversion, and the conversion says that it is 1,000 centimeter cube, which should be equal to 1 liter. Therefore, the final volume here, it should be a 7.12 liters up to 3 significant figures. So this is what your question says. The exterior surface of an inverted cone of radius 21 centimeters and perpendicular height 72 centimeters is painted to a height of 48 centimeters, right? So this is how they have painted this to a height of 48 centimeters. This shaded part is actually the painted part for this cone here. Show that the slant height of the painted surface of the cone is exactly 50 meters. They are asking you for the painted slant height. This is our painted slant height. So, and this should be a 50 centimeters. This is what we have to show here. We have to show that this should be exactly 50 centimeters. So again, I can see that there are two cones here. One is this cone, and the other is the bigger cone that we already have in the figure. So I can compare the two triangles. One is this triangle and the other is this triangle that I can have. For the smaller triangle, the height is a 48 and this is the small L, जो कि हमें 50 centimeters proof करना है. So to get the capital L from this figure, what I can see here is कि अगर मैं इसको compare करना चाहूँ, तो sorry, not compare, अगर मैं इसको find करना चाहूँ, तो I can see that this is my 21 making a right angle with the height which is given as a 72. So applying the Pythagoras theorem, I can say L is equals to square root 72 squared plus 21 squared, which is a 5625 centimeters, or square root of 5625 centimeters, that is going to be a 75 centimeters here. So L is a 75 centimeters. This L, this comes out to be a 75 centimeters. And to get the small L, I'm applying the ratio method. And for applying the ratio method, what I can see is, take the sides which are already known to you. I can see that this is a 72 and this is a 48. The two heights, I can compare the two heights, 72, 48, 72 and 48. And then I can compare the slant height 75 to the slant height, the painted slant height, which is small l. So 72 by 48 equals 75 by small l, or L then will be equal to 75 times 48 divided by 72, which is a 50 centimeters, and then this is shown to us. So this is how you will be getting the slant height shown. And then for part B, here, it says calculate the area of the exterior surface of the cone that is unpainted. Again, unpainted, right? And what do we see about the part which is unpainted? It's the part which is making the frustum. It's this part which is making the frustum, and they are asking for the area here. So how do we get the area here? The first thing is get the surface area for the part which is painted. The surface area for the part which is painted is this part. And for this part, can I say that this is actually the curved surface area of the cone? And the curved surface area for the painted cone, I'm just getting it for the painted part. For the painted part, it's the curved surface area, which should be equal to a pi RL, right? So here again, you need to know the formulas. I have provided you with the formula sheet. Please memorize that. Curved surface area is pi RL. We have calculated small l. We do not know the radius, but we can find the radius. We can say for the smaller part, for the smaller cone, we have the small l, which we just found as a 50. The height is a 48. So the radius then is going to be, I can say that the radius here is going to be the square root L squared minus height squared. Or I can say that this is going to be the square root of 50 squared minus 48 squared. And this radius then, if you calculate it, this radius comes out to be a 196, and the square root of 196 is a 14 centimeters. So I have the radius now, so I can say that the curved surface area for this cone is going to be pi into 14 into 50, which we have already calculated, and this curved surface area then is going 50 times 14 times pi, which is a 700 pi centimeters squared. Again, please see that the units are important. If you're finding the curved surface area, please do write this as the curved surface area. So this is for the painted part. We have the curved surface area. Then if I look at this whole cone, I can get the curved surface area of the entire cone. I'm getting the curved surface area of the entire cone, because I can see that if I subtract the curved surface area of the entire cone, which has the radius as a 21 and the height as 72, and the slant height, which was a 75. This was the slant height, which is the 75. So the bigger cone then will be having the curved surface area, which is equals to pi times the radius, which is a 21, times the slant height, which is a 75. And then this curved surface area comes out to be 1575 pi here. So obviously they were asking us for the area of the exterior surface of the cone that is unpainted. So if I subtract the two of them, it's actually the curved surface area of the frustum, or the unpainted part in this case. So this is going to be 1575 pi minus 700 pi, or you can get your answer as an 875 pi, or you can say that this is a 2748.89 centimeters squared, and rounding it off, the curved surface area required for the unpainted surface, that is going to be 2750 centimeters square for 3 significant figures. So this is how you will be finding out your curved surface area, which was actually the frustum in this case. So this is all about frustum. This is all I could get for frustum. Now let's very quickly do some question, and for this is the question from October-November 2011 year, paper 2 variant 2, and it's question 3. Diagram 1 shows one large circle and 5 identical small circles, right? One large circle, and then we have identical small circles here, 5 in number. So each of the 5 radii shown is tangent. Now this is the hint. This is very important. Please, when you are solving a question, underline the keywords. 5 identical circles. This is the most important thing to underline. Each of the 5 radii shown is a tangent to 2 of the small circles. Again, this part, this is very important, and this leads you to a certain property which we'll be discussing soon. Describe the symmetry of the diagram. So to get the symmetry of the diagram, what does symmetry mean? Symmetry means when you draw the line of symmetry, you will be obtaining the same figure on the 2 sides of the line of symmetry, meaning the line of symmetry or the figure should be dividing the figure into 2 equal parts. So I can see that this is then going to be my line of symmetry, which can divide the figure into 2 equal parts. So what is the symmetry? It's just one line of symmetry here. The radius of the larger circle is capital R centimeters, and the radius of each of the small circle is R centimeters. So the larger ones have the radius, which is capital R. Let's write this. This is our capital R. The larger circle has the radius, which is capital R, and radius of each of the small circles is small r centimeters. So that means if I'm taking this as the center, then this is going to be my small radius. Okay, each small circle is equal. Now, this is again the important thing to underline. It says each small circle is, mathematically, it means it is equal in area to the shaded region, right? So each small circle is equal in area. So they're talking about the area of the small circle. So let's start writing down the information that is given to us. Each small circle is equal in area. So area of the small circle is equal to the area of the shaded region, right? So area of the shaded region, what is the shaded region? It's this part here, which is actually shaded, right? How do I get the area of the shaded region? I can see that we have this sector here. And from this sector, if I subtract this small circle, the area of the small circle, then only I will be able to get the area of the shaded region. So first thing is get the shaded region. For the small circle, I know it has to be a pi r square. That's no problem. For the small circle, for the circle, smaller circle, it's pi r square, no problem here. But then what about the shaded region? So for that, what you should say is area shaded is actually, I'm redrawing the figure. You can see that it's going to make a sector here, and here it's a small circle, and this is then your shaded region, right? So for this shaded region, you have the small circle with center with the radius as small r, when this having the radius which is a capital R. First thing is, for the shaded region, you need to have the area of sector, right? So for area of sector, what is the formula? This is making the center of the circle. Let's call these points as A and B. So to get the area of the sector, we know that this area of the sector is equal to theta by 360 into pi r square, right? And then here it needs to be the capital R. So what is the angle? We are not given the angle, but they have said that it shows one large circle and five identical small circles. And with respect to that identical five circles, how many sectors do you see? 1, 2, 3, 4, and then 5. 1, this is the first sector, second, third, fourth, and then fifth. So that means this overall 360 degrees, it's divided into 5 sectors. Therefore, can I say that this theta value is actually, this theta value here can also be written as a 360 degrees divided by 5, right? Or in other words, can I have the theta value which is representing 72 degrees? Yes, I can. So area sector then is going to be 72 over 360 into pi r squared. Now, from this area, if I subtract the area of the smallest sector, then only I will be obtaining the shaded area. So area shaded then is going to be area sector minus area of the small circle, right? I'm making a circle for this respect. So each small circle is meaning equal to, each small circle is, always remember, is meaning equal to, it's equal in area to the shaded region. So the condition that I am having here is that each small circle area is equal to the area in the shaded region. So each small circle is a pi r square, and area shaded, we just said its area sector, which is 72 over 360 into pi capital R squared minus area of the small sector, which is pi r squared. Or in other words, can I say that this here is actually pi r square can be taken on the other side, giving me 2 pi r squared, 72 by 360, that's a 1 by 5 pi capital R squared. Pi and this pi, they get cancelled, or it's r squared, which is equals to 1 by 10 capital R squared. They are asking us for the ratio of r squared to small r squared. So can I say that this is r squared over small r squared, which should be equal to a 10:1. What is my answer? It's just going to be a 10:1 here. So you know what happens is when you start solving these questions, you just look at the figure and you get nervous कि पता नहीं क्या दिया हुआ है, बहुत मुश्किल है. But once you start solving it, look at it deeply. Look at what the statement is. सारी hints आपको questions में provide की जाती हैं. Like here, they have said it's 5 identical circles. 5 identical circles से हमें क्या मिला? 5 sectors which are of equal shape. Identical, 5 identical sectors I must say. और अगर 5 identical sectors थे तो हमने इससे क्या find कर लिया? We found the angles. We said all right, 360 को अगर हम 5 से divide करते हैं तो each angle for the sector needs to be a 72 degrees. So ये छोटी छोटी hints होती हैं जिनको apply करना शुरू करें तो question कभी भी मुश्किल नहीं रहेगा. So this part is solved. Then for the next part B, it's diagram 2. ठीक है? Now let's see what it says. It says that diagram 2 shows the large circle and arcs of small circles shown as in diagram 1, right? So we have these arcs here. We have these arcs here. Diagram 2, we have the arcs. Instead of sector, उन्होंने हमें सिर्फ arcs कहा है. And the circle touches the adjacent circles at A and B. Why specifically have they said A and B? Because पहले पार्ट में very specifically उन्होंने ये describe कर दिया था कि ये यहाँ पे tangent बन रहा है with respect to the radius. 5 radii shown is a tangent to 2 of the small circles, right? So 5 radii is 2 of the small circles. 5 radii is 2 of the small circles, right? So ये सब tangent बना रहे हैं. अब tangent and radius, what is the property? Radius is always perpendicular to the tangent. This is again the property coming from the circle properties. So radius is perpendicular to the tangent. So radius perpendicular to the tangent. We know this property. Therefore ये जो angle बनेगा ये 90 degrees होगा. यहाँ पर भी it's the tangent, so this angle here is also going to be 90 degrees. ये दोनों 90 हो गए. अब now they are saying show that reflex ACB is 252. ACB, reflex angle. I have to get this reflex angle. पर जब तक हम ये एंगल नहीं फाइंड करेंगे रिफ्लेक्स कैसे फाइंड हो सकता है. सो आई कैन सी कि यहाँ पर OACB इट्स मेकिंग अ काइट और टेंजेंट और रेडियस के साथ इट्स अ 90 हियर. सेक्टर एंगल हम ऑलरेडी फाइंड कर चुके थे 72. So solving this quadrilateral, the kite OACB, I can say it's ACB, which we need to find out, plus 90, plus 90, plus 72, and this is equals to 360 degrees. Solving that, I got ACB as 108 degrees, meaning this angle here, this is 108 degrees here. This is 108 degrees here. So what is going to be the reflex angle? The outer part of the circle here, this is my reflex angle. And for this, I can say it's 360 minus 108, that is going to be 252 degrees. और यही हमें show करना था कि reflex ACB is a 252 degrees. So that is shown to us. So that was, yes, tiring. I hope it's clear to everyone. Then if they are saying find the perimeter of the shaded, okay, part 2, they are saying perimeter of the shaded region is k pi r centimeters. Perimeter of the shaded region, right? So perimeter हमें shaded region का कहाँ से मिल रहा है? Perimeter की shaded region का हमें ये मिल रहा है. ठीक है? 1, 2, 3, 4, 5. How many arcs are here? I can see that there are 5 arcs. So if I just look at the arcs, I'll be redrawing the figure. I can say sector. This is going to be my sector, right? And then if I'm saying it's the arc, so ye arc is sector ka arc length hai. I should be getting the arc length here. It's the arc length of this circle, right? Having the angle, which is the reflex angle here. So with respect to this reflex angle and this radius, I'm getting the arc length here. So to get that, हमने already यहाँ पे show किया था कि ये 250 degrees है. So I'm just remaking this arc length here. It's something like this here. ठीक है? This is the arc. मुझे ये arc find करना है. So this is obviously the arc length, right? So if this is the arc length, this is my point A, this is my point B, and this angle here. All right, so with respect to the arc length, we have this arc length here. And this is my center. ये कुछ इस तरह से diagram बन रहा है. This is the center. Point C. ये angle हम find कर चुके थे. This is a 252 degrees and this is small r. They are saying perimeter of the shaded region is k pi r, right? K pi r shaded region का perimeter है. So perimeter for the shaded region is a k pi r. और यहाँ से if I look at this, then this is what I need to find out. This is my perimeter of the shaded region. ये part shade हुआ हुआ है. ठीक है? I can see that this part is shaded. This part, this completely part is the whole. It's a flower which is shaded. मगर perimeter के लिए तो मुझे यही चीज चाहिए होगी ना, which is the arc length here. So I will be applying the arc length formula. And for that formula, again, it's going to be theta over 360 into 2 pi r. And theta in this case is a 252 degrees over a 360 degrees into 2 pi r. And also, क्योंकि ये इस तरह के 5 arcs हैं, I can see the 5 arcs here. 1, 2, 3, 4, and then 5. There are 5 arcs. So I should multiply this by 5. I should multiply this by 5 and this then should be equal to k pi r. So obviously अगर मैं इसको compare करती हूँ, I need to have the value of k. Pi and r, they get cancelled. So what is your k value? You're just going to say that k then is going to be a 5 times 250 times 2 over 360 degrees. And this value that comes out to be a 7 here. So your answer for k is going to be 7. So this is how you were supposed to solve this question. So I hope we have this question. Question 9, and the diagram shows a rectangular prism, AB equals 6. There is a lot of trigonometry which will get applied here. So the diagram shows a triangular prism. AB is 6 centimeters. AB, it's 6 centimeters here. Angle BAC is 55 and the length of the prism is 20. This is the length of the prism, which is 20. And the area of the triangle ABC is a 34.4 centimeters square. So first thing is to underline that they have given you the area, which is a 34.4 centimeters square, and this is for ABC. So if you look at ABC, then ABC is actually the cross section of the prism, the triangular base area of the prism. From here, you are getting this length, which is this depth, which is a 20 centimeters. So ABC area is given to us. Calculate the volume of the prism and give the units of your answer. How to get the volume of the prism? We know that the volume of the prism is actually base area times the height, the depth. Base area is already given. It's a 34.4 and the height here is a 20. So the base area, so the volume that I'm getting here is a 688 centimeter cube. They have said give the units of your answer, right? So do not forget to write the units of the answer. It's going to be 688 centimeter cube here. So this part was simple, no problem here. It's just a 688 centimeter cube. Then they are saying show that AC is equals to a 14 centimeters. So this is, we have to show that this should be equal to a 14 centimeters, correct to 3 significant figures. So correct to 3 significant figures, you have the triangle ABC. You have A, B, and C. This angle here is a 55 degrees. This is 6, and you are given the area for this triangle, which is a 34.4. Right? I have discussed the area formula. I have said that when the area is not a right angle triangle, then I should say that area is actually half times the product of two adjacent sides. What are the two adjacent sides? AB and AC. These are the two adjacent sides that you can see. So I can say that this is half times AB into AC, and then this angle, the sine of the inclusive angle. So what is your inclusive angle? In this case, it's going to be BAC. So area is given, it's a 34.4. This is equals to 1 by 2 into AB, that's a 6. AC, I'm supposed to find AC and I'm supposed to show that it comes out to be a 14. And sine of BAC. So sine of BAC, that's sine of 55 degrees. So it's twice 2 and 6, they can get simplified. And you can say AC is equals to 34.4 over 3 sine 55. So what is your AC then? You can find your AC. So AC then comes out to be a 13.998, which is approximately a 14.0 centimeters, right? Correct to, they have said correct to 3 significant figures. So I will be rounding this off up to 3 significant figures. So 9 carried, this comes out to be 14.0 centimeters, right? So this is shown. So AC is equals to 14.0 centimeters and it's shown to us, right? So always box your answer and do write shown when you are showing something. Calculate the surface area of the prism. So to get the surface area of the prism, one method is to have this, we have the area of the triangle. That's no problem. And I can see that there are two triangles. One is here and the other is at the back. So that is no problem. But then to get the area of the side faces, the lateral faces, one side is this rectangle, then we have this sloping rectangle, and then other rectangle here. I would tell my students to get the perimeter of ABC, the triangle, which is forming the base of the prism. Just get the perimeter of ABC and then multiply it by the depth. That's the most simple way to get the area of all the three rectangular sides here. So if I need to get this A, B, and C, I just found AC, which is a 14.0. I do not have BC here. How to get BC? Again, apply trigonometry. I can see that we have two adjacent sides and the inclusive angle. So very easily, I can apply cosine formula. I can say it's BC. What is the cosine formula? It's an A here, it's a B here, and it's this side is a C here. So I can say that if I'm supposed to find the side A, then it needs to be A square, which is equals to B square plus C square minus twice of BC and cos of BAC, right? This is how I will be finding BC. And why am I finding BC? I'm finding BC because to get the surface area of the prism, I need to have this length. So BC then will be equal to 14 squared plus 6 squared minus twice of 14 times 6 and cos of BAC, which is going to be 55 degrees. And obviously, I'll be taking the square root to find the side length BC. And this side length BC, it comes out to be 11.644. Right? So 11.644 is the side length BC for the triangle. This comes out to be 11.644 centimeters. All right. As I said, to get the area, surface area of the prism, it should be surface area of the prism. Surface area, it should be twice the area of the triangle, right? Plus, I will say get the perimeter for AB plus BC plus AC. This is my perimeter for the triangle, and then multiplied by the depth. Again, repeating, I am just taking the perimeter of ABC, perimeter AB plus AC plus BC, and then this perimeter gets multiplied throughout by the depth. And when I do that, I will be getting the area of the three rectangles. One is this rectangle, second is this rectangle, and the third is this rectangle, right? So this is how simple it is to get your surface area of the prism. The area of the triangle was 34.4. So I'll just say that it is the surface area, which is twice of 34.4 plus AB, which is a 6, plus BC, which is an 11.644 plus 14, and then times the depth. And in this case, what was the depth? It was a 20 centimeters here. So this will give me the surface area of the prism. This is the easiest method that you can do to get the surface area of the rectangular faces or the lateral faces of the prism. So your surface area, it comes out to be a 701.65. 701.65. Again, it's the surface area, so do not forget to write the unit. Or you can say that the surface area for three significant figures is a 702 centimeter squared. So your answer is a 702 centimeter squared. So this is the surface area of the prism. Then we have this cuboid. Diagram shows a cuboid with a square base. Now, if it is a square base, then it means all the bases here, they need to be equal. Let's write them as L. The height of the cuboid is 8 centimeters and the volume of the cuboid is 98 centimeter cube. You need to calculate PQ. So how to calculate PQ with the given information? Obviously for this PQ, you can see it's the slant, it's the two opposite points P and Q on the opposite faces joined together. And this is what you are supposed to find out, the slant height PQ. They are making an inclined line. PQ, P is on the front and Q is a point which is on the back face. So you can see that in the plane, within this cuboid, you are having a rectangle, you're having a sloping line PQ. So volume of the cuboid is 98 and we know that obviously अगर volume दिया हुआ है तो हमें volume formula apply करना होगा. What is the volume formula? The volume formula is again base area times height, right? We know the volume, that's a 98. Base area हमें नहीं पता, but being a square, I should say it's L times L and the height is an 8. So L squared then is equals to 98 divided by 8. or this L, it comes out to be a 7 by 2. This comes out to be a 7 by 2, which is equals a 49 by 4. All right, so this comes out to be a 49 by 4 L square. It comes out to be a 49 by 4. Or further, I can say that this L, taking the square root, it becomes a 7 by 2. So this is a 3.5. Right? So I have this L, which is a 3.5. I have this L, which is also a 3.5. So if I get the diagonal here, let's write this point as maybe a R. So for this triangle R, I can very easily get my PR, and I'll just explain why I'm doing that. I have this P, let's call this point S. So PSR, and this is a 3.5. This also is a 3.5. So again, applying the Pythagoras theorem, I can say that my PR is equals to square root of 3.5 the whole square plus 3.5 the whole square. So PR then is equals to 4.95 centimeters. Right? So I have this PR, which is a 4.9 centimeters. Now you might be wondering why I got this PR. I got this PR, and I'm just showing it here, that here I have this plane, which is actually for the sloping line PQ, and still this plane is making a right angle triangle. If you look at this figure, if you look at this triangle PRQ, if you look at this triangle PRQ, what you can see is that PR is on the horizontal surface and QR is the vertical line or the vertical plane, therefore making a 90 degrees here. So PQR making 90 degrees, PQR making 90 degrees. Again, I'll redraw the triangle. It's P, it's R, and it's Q. It's 90 degrees here. PR we found as a 4.95. QR was given as an 8. Now again applying the Pythagoras theorem, can I get PQ? I can say it's the hypotenuse, which should be equal to square root of base the whole square, that is 4.95 the whole square, plus 8 the whole square, or you can say it's the PQ, which is equal to a 9.407 centimeters. Or I can say that this PQ approximately up to 3 significant figures is a 9.41 centimeters. So this is how we can apply mensuration to all these shapes. There is a lot. There are a lot of other things. There is hemisphere, there is cone. We have covered cone, but there are other shapes also. I have tried my best to explain each and everything to you. I haven't solved hemisphere, I haven't solved sphere, but in the beginning, I have solved the formulas for you all. I hope it's clear to all of you, and I'm just unmuting everyone. So if you have any queries, cancel the squares. Why would we put it in a square? Okay, why we put it in a square root? All right, because we were applying the Pythagoras theorem. So yes, you will be getting the formula sheet. Don't worry about that. Share link of WhatsApp. Okay, what's happening here?
Miss, could you repeat the frustum part again?
Frustrum part again. देखो
Yeah.
frustrum जो तो okay. So frustrum हम सिर्फ ये करते हैं frustrum में कि एक bigger cone से हमने एक small part of the cone को remove करना है to get the frustrum. Okay? हमने bigger में से एक छोटे part को remove कर देना है. Like if I go back to what we solved, frustrum हमने form किया था जब when we said के bigger cone में से छोटे cone को अगर हम remove कर दें तो हमें ये part of we will be obtaining this part which is called the frustrum. ठीक है, और फिर इस frustrum को solve करने के लिए हमें similarity of triangles की help लेनी होती है. So we can compare radius to radius. You can compare height of the small cone to the height of the bigger cone. You can compare the slant height of the small cone to the slant height of the bigger cone as well. This is what frustum is. ठीक है? Got it? Clear? Done?
Miss, how did we assume that it's a 90-degree?
किस
The
चीज में बेटा?
question, the recent question that we did for the
For
line.
the vertical plane?
Yes, Miss.
Acha. So over there, which question was it? It was okay. This was 2023. Okay. So यहाँ पर ना, this is what you are saying. Alright, देखो यहाँ पे PQ, P is on the front and Q is on the back face, right? तो अब अगर आप कोई भी डब्बे को आप इमेजिन करो, तो एक फ्रंट पॉइंट से अगर आप पीछे किसी भी पॉइंट को ज्वाइन करते हो या अपनी पेंसिल को थोड़ा सा इंक्लाइन करके देखो, तो यू विल सी कि यू विल बी हैविंग अ स्लोपिंग लाइन व्हिच इज इन दिस केस इज PQ. ठीक है? अब जो डायगोनल हमने फॉर्म किया था, ये डायगोनल ये इसलिए फॉर्म किया था कि ये P हमें जाहिर है Q के साथ रिलेट करना है, PQ के अलावा किसी और पॉइंट के साथ रिलेट करना है. What could be that point? Q going down to this point which I have labeled as R. ठीक है? Q going down to this point because I know the height of this QR, right? So I've labeled this R, and then PR horizontal plane में है, like it's on the floor. Just imagine just put your pencil on your table and then inclined it to have the line PR. ठीक है? So PR inclined है. इस R पर अगर आप एक और pencil रखते हैं, तो do you see you making a right angle triangle there?
Yes, Miss.
This is how we are getting this right angle triangle. So always for these inclined planes या 3D figures, take help of two pencils. Okay? Join them and see if you're getting a right angle triangle. हमेशा कोई भी पॉइंट अगर हॉरिजॉन्टल प्लेन पर है तो वर्टिकल उसी पॉइंट पर अगर आप वर्टिकल रखोगे वो हमेशा 90 डिग्रीज फॉर्म करेगा. ठीक है? So may I know
Ji,
your
Miss.
name?
Thank you.
Okay. Most welcome. अच्छा, I will be needing your feedback. Please, क्लास कैसी रही, आप लोगों को कैसा लगा, कितनी प्रोडक्टिव थी. आई विल ट्राई, रिकॉर्डिंग्स आप लोगों को मिल जाएंगी, और जो आप लोगों का फॉर्मूला शीट जिसकी बहुत मुझे क्वेरीज नजर आ रही हैं वो भी मैं आपके साथ व्हाट्सएप ग्रुप में शेयर कर दूंगी. डोंट वरी अबाउट दैट. सो इंशाल्लाह वो भी आपके साथ शेयर हो जाएगा. एंड ऑल to all of you, and inshallah you will do well. You will ace your exam, inshallah, and just forget about the mark result. Look forward and work for the best. Inshallah you will get the best. All right, so let's end the class then. Allah Hafiz. Khuda Hafiz everyone.